Okay, here's a very interesting example. Please imagine a torus, right? It's a donut shape, and it's definitely hollow, no filling in the donut. And let's imagine that there's a single hole poked in it. So that means that this torus shape with a hole in it does have a boundary. This little circle counts as the boundary of this shape. Is it possible to use rubber sheet geometry rules to turn this thing inside out without breaking the rules of rubber sheet geometry, without cutting or gluing? And the answer is yes. It's pretty crazy, right? Here's how it goes. First, what you do is you take that hole and you make it bigger, right? You start grabbing that hole and dragging it around. And so these first two pictures show that hole becoming bigger and being stretched all the way around to the back. So there's just a little isthmus of fabric left in the back here. And then you take that hole and you start pulling it around. So you retract that torus all the way down until there's just two little bands here, right? The red used to be the inside of the torus and the blue used to be the outside of the torus. And then what you do is you take those two bands and you rotate them 90 degrees like that. And then what you do is you take what used to be the back band and you make it bigger, and you take that front band and you make it smaller. And so then you take this thing and you rotate it again. And so what we're going to do is we're going to take that fabric and we're going to start making it bigger, right? Infinitely stretchy rubber, remember. There's not really a material I know of that can do this in real life. You grow that fabric back around, you go like that, right? Sound effects. And then you're back at this situation where there's just a little isthmus of fabric in the back, and you start dragging it back around and you grow that hole backwards until it's just a little hole. And so yeah, it's literally possible if you had an infinitely stretchy rubber torus with a little hole in it, you could completely turn that shape inside out.